Hello and good morning or good evening to you all, and welcome to my second video in our MATLAB video. Today we're going to solve the convolution problem by using the MATLAB. We have the input signal of a SN. Sorry. SN and HN for impulse response HN. But in our question, following this sequence, you have to use a MATLAB command convolution to plot by using the first 30 value for both cases in their response for question A and B. For the first part, our input in simple rectangle pause in our MATLAB. We presented this one we comment with the length of n5. N is our represent of length of input pause. If you look for formula Sn till this n is correct the signal to the start at 0 and end just before 5. So it equals to 5 1 second in a row. But in the code I will show we have to use a 1 equals to 1 n to create exact shape. For in our mathematics mathematics, our HN this one like this one is a bit tricky. Our extensional is an expansional that says our alpha is set in a negative 0.9, but it also exists in negative time because of a negative un sorry negative n like this one. Term this called an anti-casual signal. In our code, we define our time vector for negative 19 to 0. When we convert this MATLAB, the starting point of our result is the sum of a starting point of input. So H start at negative 19 and S start at 0. Our output Y start is negative 19. For example, each of our form is from our calculation for 30 value. Say our negative 1 now. For our question B, our output is Sn is an alternative decaying sequence for negative 1 over 2. The math in our math, the impulse response Hn here represent discrete difference, basically saying take the current value and subtract 3 times the previous value. In our code, like this one, in our MATLAB, we just represented H as simple vector 1 1 negative 3 like this one. Since both signals start at the time n of n equals to 0, like each of them for take example this one, is our output will start at 0. Let's start our MATLAB. Ni apa? our Sunday plot. If you see this, this is our subplot or our graph. As you can see clearly, we use the subplot to comment for each plot to let us see the input to our post response and our final output in one window. Notice I'm using stamps like this one. Command in digital signal process. We don't use line like a normal graph. We use a stamp because this are discrete point at the time. In time, sorry. For the result, in both graph, we limited the output the first value of 20 as a request. You can see how the shape imports mean or transform the value of the waveform. For example, if I did use a negative 0.9 and you run, the value takes shape for the middle of the value, we turn from negative 19 till 0. For yn, we start negative 19 and 7 till negative 1 to 6. That's all for today for our conversion. But our conversion might be a little bit weird since you use a formula, but in our MATLAB, you just define of your vector and using the conversion function for our things. For our coding, for example, and for ny and negative 19, you might wonder why do you start output at 0. In our MATLAB, the conversion function has no idea what is time for this coding. It just see the listener number because our signal, for example, Sn start as negative 19 and our signal Sn start at 0. The law of our convolution tells us that the result of yn must be start at negative 9 plus 0 equals to negative 90. We manually create this and y factor to realign to math and the graph. For this one, notice that the dot before the power sign and MATLAB. If you want to apply the exponent near every number in our array, instead, for example, matrix multiplication, you must see the dot operator. This step, the MATLAB then take this and the number of the rays, the power of every element of the vector individually. For our h equals to 1 over 3 negative 3, in our math we see the code, but for example this one, by following this formula, the computer an imports of s data n, it just add 1 at index of 0. The negative 3 until 1 is just a negative 3 of index of 1. So we can present this entire system in response as simple to mm vector 1 dash negative 3. This is a very efficient way to handle discrete system in MATLAB. For our stem, the conversion result Y is actually longer than 20 samples. By following this stem, this stem, but it says in assignment, especially as for the first 20 value, we'll be using 1 dash zone, well, 1 to 20, like this one and this one, to grab just the first slice of data in our plot. That's all for today, and thank you for your listening my question for my second video. That's all. Conversion might be scary a bit in our formula, but in our method, it just matter defining of vector by using conversion formula or function. Just follow the question and we just set it in. By following this plot, so by following this the question, we can declaring our coding from B and A for question B and question A. By running it, it can give us a one same value. Just following the question, you can get the define the value from this to this, as well this and this. So that's all for today. Thank you for watching. Assalamualaikum to you all, and good evening and good morning to you all.